Today I am going to discuss long-term project analysis, basically for investment. Project analysis depends on cash flows. As this is a long-term project, that means 5 years, 10 years, maybe 15 years also, the future cash flows cannot be deterministic, that is, cannot be forecasted with certainty, and for that reason we will consider here the future cash flows relates with probabilities. That means the cash flows with probabilities will be given, and on the basis of that we have to analyze should we go ahead with the project or not, and that's why the topics is risk analysis as probability is attached with cash flows in capital budgeting. We will analyze or apply for the decision through Hiller model. Okay, and you will see there are two situations. First case we will deal where the cash flows are non-correlated. That means the cash flows or cash inflows of one year cannot influence the cash flows of any other year. That is, the cash flows are independent, non-correlated. We will discuss first that type of case, and secondly we will see where the cash flows will be correlated, highly correlated. That means the cash inflows of one year influence the cash flows of other years. That we will discuss later on in the same video model. Okay, so that means we are going to discuss risk analysis in capital budgeting by Hiller model. Okay, this model is used to evaluate project under risk, that is, cash flows for project are available with probabilities. We will discuss through a practical problem and focus for analysis on expected NPV. NPV means net present value, and standard deviation, that is the risks of NPV. Okay, so this is the first case. There is a non-correlated cash flows. How we determine the expected NPV? This is the formula. I am not going to mention detail. It is, everything is written here. CT is the expected cash flows for year T, and this is I is the discount rate, I is the investment, all this. This is the formula, and we will discuss through a problem. What is the problem that I am going to discuss? And this is the formula for finding out the risks in the case of non-correlated cash flows case of Hiller model. Okay, now this is the problem by which we will discuss the entire topic. This is the Hiller model for selection of a project. The economic life of a project is 3 years. Here we are considering the life of the project is 3 years. Okay, and year-wise cash flows with probabilities are noted as below. This is the cash flows data. This is year 1, year 2, year 3, and this is the cash flows for year 1. The probability for cash inflows rupees 3000 will be 0.3, and the probability for cash inflows rupees 5000 0.4, and the cash flows probabilities for 7000 0.3. In this way, for each year's first year, second year, third year, the data are given on the basis of past experience analysis. These are the data. What we have to do? We have to determine the expected NPV. What will be the expected NPV of the project? Why we are calculating it? If the expected NPV greater than 0, then we will go ahead or select the project for application. How much risk is involved? For that you have to calculate the standard deviation of NPV. So first we will learn how to calculate these two items, expected NPV and standard deviation of NPV. Okay, and after that we have to calculate the probability that the project should be rejected, that is the NPV less than 0. That is also I will show you how to calculate it. There is no correlation among the cash flows, which I have already mentioned. This is the first case, and later we will discuss the case for correlation of where the cash flows are correlated. How we have calculated. For better understanding, I am going to show you through Excel sheet, then it will be clear, the calculation part. Okay, now we are going to the Excel sheet. I am solving the same problem, that problem which just now I have discussed. This is the problem. This is initial investment one, 10,000, and this is the year-wise cash flows. 3,000 probability is this, 5,000 cash inflows probability is this, 7,000 cash flows. Just now I have mentioned it. You can check it. And if you sum all these probabilities, then you will get 1. As we know, the sum total of the probabilities is 1. In this way, for second year, the cash flows with probabilities are noted here for the same problem, and for third year also noted here. Okay. Now I am going to show you the calculation. If this into this, then the value is net cash flows for this value. Net cash value, this is the, you can say, expected value. Sorry, this is the expected value. This into this, 3000 into 0.3 means 900. This is the expected value for this value. In this way, this into this is the expected cash inflows for the first year for this value, and this into this, that means 2100 is the expected cash flows. Then what is the total expected cash flows for first year? That is 5000. You add this. You can check the formula. You can see the formula also. This is the formula. This is the formula for calculation. I have noted here. If you change the value 4000, automatically this value will change. You can check it also, but I am not doing that just to wastage of time. The formula is noted here. This is the formula, and this is the sum total. Sum of D7 to D9. D7 to D9. That is the expected cash inflows for first year. In this way, expected cash flows for second year is calculated here. All formulas are given here. If you change any value, instantly, immediately, the value will be. I am showing one. Suppose instead of 4000, I am doing it 5000. You can check it because I have given the formula 5000. Sorry, I am going to give it instead of 4000, 5001. This is the 5000, and see, immediately the value is 3000, and previously it was 4000. How much it was? This is 2400. In this way, okay. The cash flows, expected cash flows year wise are noted here, calculated here with the Excel sheet. Okay. Now, what will be the expected NPV? The discount rate is given 6%. That means the capital cost is 6%, and the calculation, the entire formula is noted here. Actual formula, D10 divided by 1.06. Why 1.06? 6 is the discount rate. That's why divided by 1.06 into what will be the power? The first is 1, then second 2, then 3. In this way, the entire cash flows has been calculated here, and that is 2475. You can note it. I will show you. It is also shown in the main presentation. Okay, and these are the values of standard deviation, sigma 1 square, sigma 2 square. I have shown two calculations in this way. Third also calculated same way. How it is calculated? Sigma 1 square, and this is the expected. That's my what you have to do, 3000 minus 5000 square into 0.3. That is the formula is noted here also. 3000 minus 5000 square into probability 0.3. In this way, second 5000 minus 5000 is the mean value into square 0.4. In this way, sigma 1 has been calculated, which is 24 lakhs. Sigma 2 square, the same way the formula is calculated here. 4000 is the expected mean value. That's why 2000 minus 4000 square, 2000 square into probability. This is the formula. You will check it. And sigma 2 square will be 16 lakhs, and sigma 3 square will be 24 lakhs. Now again, we are going back to the original PPT. Okay. So these are the calculation part which I have done through Excel sheet. Okay. Now moving to the next sheet. This is the expected NPV, and we have noted 5000 divided by 5000 divided by 1 plus 0.06. C2 4000 divided by, this is the square. Why square? After 2 years, that's the discounting factor will be square, and for after 3 years the expected cash flow is this divided by to make it present value. In this, the minus initial investment. If you apply this formula, this is I is equal to 10,000. You will get this is the expected NPV. Now I am showing in the next slide the expected standard deviation. Sorry, sigma NPV. Okay, the sigma 1 square I have shown you. The value is 24 lakhs. Sigma 2 square already I have shown you. You can check it, and this is third year value. Then what will be the sigma NPV? This is the formula. That's why what I have done, this square 24 lakhs divided by 1.06 square, because this is the formula. Sigma 1 square divided by 1 plus discount rate is 0.06, and 2 into 1, T is 1 first, and then T2 means 4, and T3 is 3. This one for getting the standard deviation, this is a square root for that. If it is variance, then it is not required. So after calculation, you will get the standard deviation is this. The expected NPV I have shown you in the previous slide, and this is the standard deviation value. Okay. So in this way, you can calculate the expected NPV. Expected NPV is 2000, 4000, so 2475 rupees, and the risk is 2258. Okay, and then probability that NPV is less than 0. This is a statistical method by which you can calculate the acceptance probability and what is the probability for rejection of the project. For that, what you have to do, you have to calculate the Z value. How you will calculate it? Z is equal to Z square value. When you have to calculate risk of loss. Loss means NPV is 0 and negative. That's why 0 minus NPV to sigma of NPV. This is the formula. So NPV, what will be the probability for the NPV is 0 and negative. That's why you just put the value of this is 0 and expected NPV or NPV formula is the value is this, and this is the standard deviation value, and you will get this value. Z value is this. That means up to this, and you can check the normal probability distribution curve, and from that you will get this value. We will discuss another video how to find it through graph paper. The cumulative probability up to 0, below 0, up to 0 is this, that is 13.79%. This is the chance that the project NPV will be 0 or negative. That means the project will be rejected. That percentage is 13.79%. Okay, that means acceptance probability will be 1 minus 0.1379. The difference will be the acceptance. Okay, the conclusion is the projects gives a positive NPV, expected NPV value is this, the risk for the project is this, and the probability of loss, that is rejection of the project, is this. Therefore the project is acceptable considering both risk and return. Okay, now I am going to discuss the other case of the Hiller model, that is when the cash flows are correlated, that is the cash flows of one year is influenced or relate with the other years. In that case, the expected NPV formula is same, but the risk formula is different. The formula will be this. The detail is noted here. In this case, it is not required to square it. Simply, it is to be added and divided by this. This is the formula. And the same problem we have calculated with this formula for the case of correlated cash flows. You will see this is that sigma 1 square value, and this is sigma 2 square value, and we have square root it to get sigma 1, and then you will get the value of risk is this. You can see the value of risk in the case of correlated case is higher because you cannot diversify it. In the case of non-correlated case, you can diversify the risks. That is the reason. Then this is the case by which you can calculate the expected NPV and risk also by using Hiller model. This is all about our discussion today. So what we have learned? We have learned how to find out the expected NPV and expected risk, or you can say standard deviation for both the cases when the cash flows are correlated, when the cash flows are non-correlated. We have first discussed the case of cash flows when they are not related, and secondly we have discussed the case of correlated. Okay, yeah. If you have any doubt, any questions, you please note to the comment box. I will definitely reply at the earliest possible. Okay, no problem. And if you like this, then definitely you put a like, comments, and also may share with your friends. And please wait for the future similar type of videos. And next I'm going to upload another video relating to capital rationing, how use capital rationing for capital budgeting. That we will discuss in my next video. Thank you.